Hello students, today we are going to continue after the second lecture. I hope you all have seen the second lecture and your doubts are clear. So today we will learn how we can convert any base to its decimal equivalent. Okay, so we will start with binary. Now you will say, okay, ma'am, we have already done binary. We have already completed binary to decimal. Okay, yes, we have. But let us see another form we have not done for the decimal points. So we will do that. So suppose if we have a number like 1011 dot 01. So this is a binary number which has a base 2 and we have to convert it to a decimal number or its decimal equivalent which is a base 10. So how are we going to do? Only for binary number without any decimal point we have already done. So how do we go about? So 1, 2, 3, 4. 4 digits are there. So there will be 3 powers like 0, 1, 2, 3. Okay, we don't need to write once you figure it out. This is only for your understanding that I'm writing it over here. Okay, so how are we doing? 1 into 2 to the power of 3 plus 0 into 2 to the power of 2 plus 1 into 2 to the power of 1 plus 1 into 2 to the power of 0, right? Then we'll have a decimal point. Again, we'll continue from here. So this will be 0 into 2 to the power of minus 1. Okay, this will be minus 1, this will be minus 2, and so on if there are other numbers. Plus 1 into 2 to the power of minus 2. All right. So now we are going to calculate this. So what will be the calculation? This is 8 plus 0 into anything is 0 plus 2 plus 1 dot. What will be this? When we write, oh, this is multiplied by 0, so that becomes 0. All right. And then plus this will be 0.25. All right. So what do we get? 8 plus 2, 10 plus 1, 13.25. This will be our decimal equivalent for this number, 13.25. Is it clear to all of you? So this, we have seen how we can convert a binary number with a base 2 to its decimal equivalent. Now we will see octal to binary. Okay. So octal has a base of 8. Sorry, octal to decimal. Right. So octal has a base 8. We have to convert it to its decimal equivalent. Okay, so how do we do that? We'll take any number which has a base of 8. So suppose I'm taking 23. Okay, you can take decimal also. So 23.12, suppose. Okay, so it is a base 8. All right, you have to convert it into its decimal equivalent. How are we going to do this? Same way, we'll just number how many digits? 0, 1 from here, and this will be minus 1, minus 2. Okay, now since it has a base 8, so how are we going to do it? 2 into 8 to the power of 1 plus 3 into 8 to the power of 0 dot, this will be 1 into 8 to the power minus 1 plus 2 into 8 to the power of minus 2. Okay, now let us calculate. So 2 8s are 16 plus this, anything to the power of 0 is 1. So this is 3 dot. Now here it will be, if you have 8 to the power of minus 1, that means 1 divided by 8, which will give you 0.125 plus, same way if you do this one, so 2 divided by 8 to the power of 2. Okay, so 8 to the power of 2, if you do, you will get 0.0312. I'm taking up to, let's take up to 3 decimals. Okay, let us take up to 3 decimals. So in that case, if we do our calculation, 16 plus 3 is 19 point. Now let us add this to up. So 0.125 plus 0.031 will give you 0.156. Okay, so 156. So this will be the decimal equivalent of 23.12, 19.156. All right, we can also seeing that here we have only up to 2 decimal places. So here also we can keep up to 2 decimal places. Okay. All right. So this was octal to decimal. Okay. Suppose you don't have a decimal point number. So how you're going to do it? Let us take another example where simply we don't have any decimal point. Then in that case, how are we going to do? Suppose we have 42, an octal number. You have to convert it to a decimal number, to its decimal equivalent. How are we going to do it? Same way, 0, 1. So 4 into 8 to the power of 1 plus 2 into 8 to the power of 0. Very simple. So this will give you 32 plus 2, which is 34. So the answer will be 34. Okay, I hope this is clear to all of you. So our next topic would be hexadecimal to decimal. So in the same way we are going to do for the hexadecimal also. Let us see, let us take a simple example. Hexadecimal. By now you all must be knowing hexadecimal has a base of 16, right? So we are taking a number, suppose 25, having a base of 16, and you have to convert it to a decimal number with a base of 10. All right. So by now, I hope you all are very clear with what you have to do. So 2 into 16 to the power of 1 plus 5 into 16 to the power of 0. So this is going to give us 16 twos are 32 and plus 5. So this will give us 37. All right. So this is the decimal equivalent of a hexadecimal number with a base 16. I hope all these things are very clear to you. In our next topic, we will discuss about binary coded decimal, binary addition, complements. Okay, so in the coming topics, we will be doing all these. I hope you understood the video, understood the lecture. If you have any problem, you can mention that in the comment section and let me know. Thank you and take care.